Hello and welcome to section 6.6. There's a lot of answers to go over, so take a look at your 6.5 answers. You can pause the video as needed. I tried to highlight most of the answers here because there's just a lot of words here. Hopefully you reduced your radical for number 23. Number 27 is kind of important. We've came up in one of our other problems, and it came up in this problem, and it's going to come up in the future. If you have similar triangles, the ratio of the areas is you take the ratio of their scale factor or their side lengths, and you square that. That gives you the ratio of the areas. That's pretty important, actually. And HL in number 34 does actually work. Use the Pythagorean theorem. So the HL similarity works. So if you have two right triangles and one of their legs are similar, or one of their legs and their hypotenuse are proportional, then the two triangles are going to be similar. So that's kind of neat too. I'm going to go over three theorems using Sketchpad, Geometry Sketchpad, and then I'll put the three theorems on the board. You can take the notes on them, and then I'm going to go over some example problems. So I'm doing most of this video from my desk actually. So here's the first one, 6.6, triangle proportionality theorem. All right. So here's what we got going on. I took a triangle and I constructed 2 points, D and E. It doesn't really matter where D and E are. DE has to be parallel to AC. So D and E, it's irrelevant as to where they are. But what happens is, let's do calculate this divided by this. Okay, so, and then I'm going to do the other one, this divided by this one here, EC. And you'll notice that it's the same. So this over this equals this over this. And like I said, you can move these here. Doesn't change anything. And you can move this here, and they still stay the same, or they stay equal. So that's the first theorem. Now if you had done this divided by this equals this divided by this, you're going to get the same answer. That works too. There's a lot of different proportions that you can set, but this has to be parallel. And then I'll come back to all this stuff here. Do the next one. This one, we got a lot of transversals here. We have two lines here. Here's our two, this one, and then we have three transversals, three parallel transversals there. And what happens is another proportion comes up. And if you do AB divided by BC, and then if you do DE divided by EF, you get the same answer. You could do AB over DE, you could do BC equals BC over EF, you're going to get the same thing. So, but these three lines here have to be parallel for this to work. And then the last one is an angle bisector. Okay, so if this is our angle bisector, so here I have ABD is 35.57, CBD is 35.57. Even if I move that, I've kept that segment there. You'll see that this ray isn't always going to be an angle bisector. So what you can do is you can take this divided by this equals this divided by this. So I'm going to show you guys what that looks like. AB divided by AD. Okay, that's 1.67, and then BC divided by CD, 1.67. And like I said, you can move this triangle around and change the shape of it, make it obtuse, make it a right, make it acute, and it still works. So there you go. And going to be a little bit of notes here to take, but here's the first one. Now the converse also works. This is another way to check to see if these lines are parallel. If RT divided by TQ. So this divided by this equals this divided by this. Then these two lines are parallel. If they are parallel, then this divided by this equals this divided by this. So the converse holds there. And then the two other ones here, UW divided by YW equals VX divided by XZ. And could you say UW divided by VX equals WY divided by XZ? Sure, it's going to be the same answer. And then the last one, you have AD divided by DB equals CA divided by CB. Could you do AC divided by AD equals CB divided by BD? Yes, you could do that as well. There's a lot of different proportions that work. Just make sure you're matching up the segments in the corresponding segments, basically. Okay, now that we have all of those notes down, let's give this a try here. And we're just going to solve some problems. Probably go through this kind of quickly. I'm not going to solve all of them. I'll just set up the proportions for what you'd use. Okay. Alright, so the lines are parallel, so we can do 4 divided by 6 equals, we'll call this x divided by 9. There you go. On the shoe rack shown, AB is 33. Okay, AB is 33. BC is 27. CD is 44. And DE is 25. Explain why the gray shelf is not parallel to the floor. So what I do is 27 divided by 33 equals 44. I just want to make sure I have my numbers right here. CD is 44, DE is 25. Okay. And I would do the cross product, so 27 times 25, 675, and then 33 times 44 is 1452. Well, those aren't even close. Okay, those would have to be equal. They'd have to be proportional. So, there you go. AB is 33, BC is 27. Gosh, that just looks, I don't know, it looks really bad. The 44, that just kind of looks weird to me. But, yeah, those two aren't equal. Therefore, they're not parallel. Okay, find the length of YZ. We'll just call that X. And again, we can do 44 over 35 equals 36 over X. Cross multiply. And then determine whether these are parallel. So let's do 50 divided by 90, and let's check to see if that's equal to 40 divided by 72. You could either, another way of doing this, I'll show you, 50 divided by 90 is 0.5 repeating here, and then 40 divided by 72 is 0.5 repeating, so yes. So that's another way to check to see if they're parallel. You just reduce the fractions. Okay, and then we got this one here. These three angles are congruent. Therefore, these lines are parallel. Corresponding angles. All right. GF is 120. DE is 150. CD is 300. Find the distance HF. So we want this here. So what I'm going to do is I'm going to figure out what that is first, and then I'll add 120 to it. So 120 over X equals 150 over 300. Well, if that's a 1 to 2 ratio, so this has to be 240 right there. So this is 240 plus the 120 equals 360. And there's your answer. You could also cross multiply, you're going to get the same answer. Okay, so here's the triangle one. We're going to call this guy right here, if this is X, then QR is 15 minus X. So we're going to do 15 minus X over 7 equals X over 13. And then we'll cross multiply. I'll actually solve this one. This is a good one to solve. 13 times 15, just going to use my calculator here, is 195. 13 times negative X is negative 13X. And we will add the 13X to get 20X equals 195. And then divide by 20. It looks like we're going to have a decimal. That's okay. 195 divided by 20 is 9.75. Let's try that again. So once you know the theorems, all these problems are really quick. I did this problem wrong. No, I did it right. Okay, sorry. I thought that I did the wrong. I did that part over that part, and then I did that part over that part there. So, yeah, I was just making sure I set up my proportion correctly. 15 over 18 equals 16 over x. Not going to solve that one. This one I'm going to solve, though. 4 over 4 root 2 equals, we'll call that x4 over x. I can reduce the 4 and the 4 here to 1 over root 2, and that will make the problem a little bit easier, actually. So cross multiply, and you have 1x equals 4 root 2. So there's your value of x. So you'll see here that I reduced that fraction. You can do that. You'll get the same answer if you don't, but if you recognize that, you can make the problem a little bit easier. Okay, I got a couple challenge problems in there. They are definitely challenge questions. So if you want a bit of a task for you, give those a try. If not, the other ones are there. Thank you, and I'll see you.